I remember quite sharply the first time I interacted with a Macintosh. I was 10-year-old and my mother had to take me to a workplace and she wanted me to stay quiet. So she put me in front of that new computer that just arrived and she said, well, do whatever you want, but don't bother me. So I stay seated and it actually worked very well because I explored the different software that were there, I explored the mouse for the first time and I stayed quiet for, I think, the whole day. Basically because I was not in a workplace anymore. I was inside that computer and I stayed there for a whole day. Year after year, I discovered that there were other things to do with computers, that you could play games, that you could program games, you could spend nights playing games inside that computer, not being in your small rooms anymore. More recently, I started to use computers like most of us for doing more and more things for which computers were not initially intended for, like listening to music. Typically now on a Sunday morning, if I want to put some music, I wake up and I go and open my laptop, and then something happened a bit weird because I discovered that there are some Facebook change, Twitter, blah, blah, blah. And typically after half an hour, my wife is calling me and say, what do you do? And I still not have put the music on because I'm trapped again inside the computer. I used to do that in a much more simpler manner. Take my CD, put it on, go and prepare the breakfast. Very recently, I bought an iPhone and things have been getting worse because now I'm actually walking to work, looking at my iPhone, and very strangely enough, you manage to do that. I mean, you're walking like that, and you don't, well, sometimes you bump into people, but in most of the case, you don't bump into people, and you're inside the iPhone now, not with your co-travelers to work. And guess what? You can do also that at home. I mean, you're just at home, and then you're up, oops, inside your iPhone, and you're not with your family and with your kids, etc. Now, of course, there is an issue. Actually, my wife complained, my kids complain. Not so much about the activity, because it's legitimate actually to talk with other people. I mean, it's legitimate to play some music, legitimate to get some information, but it's the interface which is not right. It's a personal interface, and it's great for that. But there are some situations in life where, I mean, getting away from where you are is not so much appropriate because there are other people there. So that's why, I mean, with industrial designer Martino Desposito, we've been thinking about, would it be possible to build something that would not so much be a personal computer, but more like an interpersonal computer? A computer you could use while still interacting with other people around. Basically, it's what I call computers to live with, not computers to live inside. So in the last 3 years, we did research on that, and we came up with that particular machine, which is called QB1, and which is a strange machine. As you can see, it is motorized. There is a fabric skin, not some plastic covers around it, and under that fabric skin, there are some silent motors. That means in some way it can turn its head, a bit like what we do in everyday life. I mean, when someone is there, you turn your head towards it, and it means you're in some way interacting with it, even if you don't exchange some words. There are some microphones, 2 microphones, one on the right, one on the left. It means that the system can know which direction the sound is coming from, a bit like what we do. And if you look closely at the head, there are these strange white dots there, which are small pulsed infrared LEDs. And that's a system we've been developing at EPFL, which is actually a depth perceiving camera, which is using this active lighting to reconstruct some 3D image of the scene the system is seeing. So it looks a bit like that. Like when someone is approaching the screen, you get basically both X and Y information, but also the Z information. You know how far is that person, whether she's holding something in her hand, etc., etc. And also you can use the system to do face tracking and also face identification. That means that that system can actually know who is there and potentially adapt to that information. In addition, of course, you can do also some form of context awareness based on detection of visual tags. I mean, you can stick things on objects, so like the system can know that you're interacting with a special piece of paper or a special object or special t-shirt, etc. And basically, and I will come to that, that will permit to interact with a system, a bit like what we do with humans, basically at a distance, not touching the system, this is not a touch screen, but interacting at 1, 2, 3, 4, 5 meters by gesturing. But we'll see that it's not completely obvious how you do that, and I'm going to talk a bit about how to design such a, not a graphical user interface, but a physical user interface. Basically, and that will be really my main message for today, QB1, that's the name of the device, is here with us. It lives in the same physical space as we do. And that is very, very different from more traditional computers. Okay. So what does the system perceive, and how can we construct an interface so that you can actually do some of the things you do with normal computers with a device like that? So as I told you, it perceives faces. So a user initially is a face. But it's also some movement based on the arm of that person. So we've been studying a lot how people were spontaneously gesturing in front of that device. And it actually, I mean, it's actually possible to define different zones in this movement. Obviously, I mean, gestures in human interaction, they are very rich, very complex. But very basically, we can say, okay, if we want to create a system that will be centered on that user, we have this rectangular screen. So we must have the system facing the user and having the user in the middle of a space, which the center should be that part here. And then if you take that as being the center of the interaction, then you can discover different type of zones. Here there is a zone, which we call a blue zone, which is basically very noisy, in the sense that as I'm speaking now, I'm gesturing, you see. So if you use that zone as a way of doing very important things when you interact with the computer, there's a high risk, because here you have too much interactivity. So you may just do this and create, well, an unexpected or unwanted comment, for instance. But here, there is a zone which is much less noisy. In a talk like this one, it's very rare they will do this, you see. And it's like that in everyday life. So we're going to say, okay, let's move step by step. If you want to organize an interface around that person, here we're going to create some widgets, basically, or physical widgets, which needs a lot of regularity when you interact with them. That means that we want to be sure that this gesture is intentional. Where here, we can create buttons which are much more reactive because there's much less noise up there. This is the first application we did for music interaction. Here, we've been putting some slide bar where you have different albums. And to slide them, you need to do this very regular gesture like this, which are gestures you don't do unexpectedly. It needs to be like periodic and regular. Here, on the contrary, you can have buttons which are very reactive. You just need to do this to interact with them. You can have a slider here, you just grab the slider, move it like that. So this is how it's looked like. So you see the system is always adapting to the position of the user, and the user sees a representation of itself on the screen, and it just basically using its own image touch the element like that. Here I'm grabbing a slider, you see, at a distance. It goes very fast. If I want to do some form of movement which is more regular, then I can do this type of movement in the lower part of the interaction system. What is very important to understand is that when you see this interface, it is really centered in the physical space of the user. That means the buttons, they are not on the screen, they are there. And actually, if you move around, they move with you. Okay. So let's see how it works in a standard living room, more or less standard living room. The system is actually projecting the interactivity zone, what we call a halo, onto the person it is interacting with. Here, this small little girl here. She can, with gesture, as we've just been seeing, trigger some event, choose a song, choose a film on the TV. That's an example. But you can also grab the attention of the system by calling it. We remember that there are the two microphones there. So I mean, if you call it exactly like a person, it will turn its head, look for a face, and go towards the person it perceives. That's what the two parents can do here. And if they don't like to gesture, they can just show a card with a special tag that will maybe launch a given music at that time. That means you can also use objects to interact with the system, in a bit like what you would do with other humans, basically. Now there are some design questions when you design a system like that. And one which is very important is the representation of the user. We've been oscillating in the last 2 years between a lot of different choices. This one was one of the first systems we built where the user would see itself really and see the buttons around him. We tried different things like the whole walls, you could pass like that, etc. This is what we are called realistic representation of the user. We also tried very iconic one where the person would actually basically control hands at a distance and go like if it would have two mouses basically and browse into the system. This is what I call iconic representation. This choice is not just like a small design choice. It's actually very important because there is this continuum between a realistic representation and an iconic representation, and this maps directly between the perception of the user on whether he is in the physical space or whether he is in the virtual space. You may have heard about Project Natal by Microsoft. They gave a very impressive demonstration. It's interesting that in the demonstration they've been showing, they really took that opportunity, that design choice of putting the user in the virtual space. They decided that, okay, you are now the controller, you don't need anymore to hold something, but still, you're playing a game which is almost like a traditional game, in the sense that you're controlling a character in a virtual space. That user, although she is gesturing, she is inside that TV. We've been trying to do something different. It looks almost the same, but I emphasize that this is slightly different. Here we have a system which is a tennis playing game where users actually can interact and play tennis. But they don't see themselves as character in the screen. They see just a small shadow of themselves, and then the ball is in augmented reality. That means they're playing really in the physical world. And people get it very rapidly. There was no like tutorial or anything to play a game like that. You see yourself, and you just see that just this element in addition which is visible. And what is interesting, because you're in the physical world, you can use many different strategies. Here, that guy is using the two hand to do to play the tennis. You see, that guy is playing alone. If you grab an object, you can use it to play. It's because we use this 3D camera to just get the physics information about the scene, and then everything goes. You're not anymore really in the game, you are in the real world, in a real physical world situation. So gesture-based system, and that's an additional point, can know a lot about you because they live in the same physical space. You have really, with such a system, a new kind of intimacy. Typically, the more you spend time with them, the more they can learn. And that's what we actually implementing now that we have our first customers, actually, which are a bit pioneer and which have now the system at home. If you interact with the system over days, then the system can basically learn a few things about the way you play your music, typically. It will just record at what time you play each song, okay, that's fine, but it also records what are the person present in the room. Here, typically, there's a song in the morning for the breakfast where the couple is there, and then maybe there's just the person B here, and then there's some guest here, but that the system doesn't know. There's A and B and 2 question marks. And obviously, you play your music and you choose your music differently depending on that contextual information. So that enables to have a system that in a given situation, like 22:30 p.m., is capable of deciding, okay, there's A and B, there's this two person I don't know, maybe I'm going to choose this music based on the past choice. This is only a beginning, just to tell you that by essence, the fact that you can interact at distance means also that you have a new kind of intimacy with the computer, and that could be used in an interesting manner. So just to wrap up, obviously, the mouse did not kill the command lines. So to all the person, when we show this demonstration, they say, oh, this is the end of the mouse, this is the end of the mouse. Well, probably not. Gestures will not kill the mouse either. But basically what they do is that they open a new kind of relationships with computer. And we're just starting to explore that. Basically, computer to live with and not computer to live inside. Okay, so if you want to join us in this adventure, we have now an SDK for developers, so please contact me if you want to develop your own application on that platform. And I thank you.